So far we've used the square root methods and solve by graphing to solve a quadratic. So when you're solving a quadratic, what you're trying to do is think of numbers for x such that when you plug them in, you'll get the left-hand side equal to the right-hand side. So we solved by square roots, which works when b is 0. We solved by graphing, but you have to graph. So one method that you can use is solve by factoring, and that's only going to work if you can actually factor. So we're going to use the zero product property. So the zero product property is if you have two expressions that are multiplied and the product of that is 0, then that means that a has to be 0 or the other expression has to be 0. So that's going to come into play. So when you solve, you're going to set one side equal to 0. You're going to factor it if it's not already factored, and then once it's factored, you're going to set each factor equal to 0. So don't forget that you can have factoring methods as you can group, you can have perfect square trinomials, you can have difference of squares, you can have the greatest common factor. So just factor it like we did in chapter 9. So example 1, solve each of the following. So if I look at this first equation, I already noticed that one side is equal to 0. Then I'm going to factor out, but it's already factored. So once I factor it out, I'm going to set each factor equal to 0. So what it looks like is I'm going to set 3x plus 1 equal to 0 and x minus 5 equal to 0. So when I solve for x, I'm going to get x equals negative 1/3. I subtract 1 and divide by 3, and I'm going to get or x equals 5. So this has two solutions. Okay, letter B, I notice that one side is already equal to 0, and this is already factored. So I'm going to set each one of these factors, don't forget about the x on the outside, equal to 0. So I set x equal to 0 and solve, but that's already solved. And I set x minus 4 equal to 0 and solve. So that is x equals 4. And then letter C, I'm noticing that I already have one side equal to 0, but this isn't factored. So what I can do is I can factor out by greatest common factor and take out an x. So if I take out an x, I'll have left 3x minus 4 on the inside. Now I can use the zero product property and set x equal to 0 and 3x minus 4 equal to 0. When I solve for x, I get x equals 4/3. Letter D, I want to get one side equal to 0, so I'm going to subtract x from each side. So I have 5x squared minus x equals 0. So the same technique applies. I'm going to solve by factoring. So I'm going to take out an x. And then I'm going to set each one of these equal to 0. So x equal to 0. Or if I set 5x minus 1 equal to 0, I'm going to get 5x equals 1, x equals 1/5. And then letter E. Now this one I would normally just solve by square roots by adding 49 and dividing by 4. But I'm actually going to factor this. This is technically difference of squares. So this factors into 2b plus 7 and 2b minus 7 equals 0. So then I'm going to solve, set each one of these equal to 0. So I have 2b plus 7 equals 0, and then 2b minus 7 equals 0. So then if I solve for b, I'm going to get b equals negative 7/2 and b equals positive 7/2. Okay, letter S. I gotta get one side equal to 0, so I'm gonna subtract 50 from each side. I always try to have this leading coefficient be positive when I factor. So it's gonna be y squared minus 5y minus 50 equals 0. So now, to factor this, I cannot factor by greatest common factor or difference of squares. So I do factors of negative 50 that add up to negative 5. So that's going to be y minus 10 times the quantity y plus 5 equals 0. Because negative 10 plus 5 is negative 5, and negative 10 times 5 is negative 50. So then I set each one of these equal to 0, and I get y equals 10 and negative 5. Okay, letter G is, I already have one side equal to 0, and I can't do a greatest common factor. And I'm noticing that out front has a 6, so I can't just do factors of negative 5 that add up to negative 13. I'm actually going to multiply and do factors of negative 30 that add up to negative 13 and factor by grouping. So right away I'm thinking 10 and 3, but negative 10 and negative 3 will not give me a negative 30, it'll give me a positive 30. So the other choice is 15 and 2. So 15 times 2 is 30, 15 and 2 is going to give me negative 13, so it has to be a negative 15. So I'm going to write negative 15 right here. So now I'm going to factor by grouping. So I have 6d squared. Now instead of writing negative 13d, I'm going to replace it with negative 15d plus 2d, and I still have minus 5 equals 0. So to factor by grouping, I do the greatest common factor of the first two terms, which I can take out a 3d, and I'm going to be left with 2d minus 5. And I can copy out 2d minus 5 over here, and then I must have factored out a 1, and so I put plus 1 right here. So in the end, I can make a binomial of 3d plus 1, and I make a binomial of 2d minus 5. So since I'm solving, I need to set each one of these equal to 0 by using the zero product property. So I set 3d plus 1 equal to 0, and 2d minus 5 equal to 0, and solve for d. So subtract 1, so 3d equals negative 1, so d equals negative 1/3. And then if I add 5 and divide by 2, d equals 5/2. So letter H, I need to get one side equal to 0. So I want to get that leading coefficient to be positive. So it's going to be 6x squared minus 21x minus 12 equals 0. Then I can actually factor out a 3, a greatest common factor of 3, out of everything. Oops, I don't know why I wrote 4. Looking ahead, this should be a 7. Okay, so after I factor this, I need to factor this by grouping again, because the leading coefficient of x squared here is a 2. So that means I have to do factors of negative 8 that add up to negative 1, or negative 7. So that's going to be negative 8 and 1. So it's going to write 2x squared minus 8x plus x minus 4 equals 0. Notice how I'm still keeping the 3 on the outside. Then I'm going to have 3. I'm going to factor out this part by grouping. So I factor out a 2x and get x minus 4 plus 1 x minus 4 equals 0. Then I take my outside, which is 2x plus 1. I still have the binomial x minus 4. And then on the outside is the 3. So you want to use the zero product property and set each factor equal to 0. But you're not going to get anywhere if you set 3 equal to 0, because 3 doesn't equal 0. So if it doesn't have a variable, you don't need to set it equal to 0. But I'm going to set 2x plus 1 equal to 0, and I get x equals negative 1/2. And I set x minus 4 equal to 0, and I get 4. So those are my two answers.